Hello everyone and welcome back. I'm going to pick up again today by talking about some more software. So you look, you can see I'm on my YouTube page and I'm highlighting MyRobotLab software part 1. Well, I'm going to do a part 2. The reality is part 2 is kind of a do-over or a start over because I'm changing the software that I'm using. I'm moving from the new test version of Nixie back to the old stabilized version of MyRobotLab. So, like you can, like I'm saying, it's kind of a start over, but I'm going to leave the part 1 up because eventually it's going to be meaningful. So the first thing we're going to do, we'll go back to the MyRobotLab homepage. Under Build Yours, MyRobotLab, How to Start MyRobotLab, we'll open this page. Now, when I first got here, this psst caught my attention. So what I did was I went to that page and I liked what I saw. And that was the Nixie development release. And that's the one with the all web browser interface. Really, really nice, guys. When it's finished, you're going to love it. However, as I've used it, I've come to the conclusion that it's not yet ready for prime time. So I've had to back up and I've gone back to the Manticore stable release, this release down here. I've gone back to it. And the reason I did was it actually works. I did learn enough using the Nixie version that when I came back to the Manticore version that I actually found I knew more now than I thought I did, and it wasn't as confusing for me. But before we go any deeper, let's kind of look at that name. That's a hard name for me to pronounce, and I didn't even know why they chose that name. So I looked it up, and it's a legendary animal having the head of a man, the body of a lion, and the tail of a dragon. And it comes from the Persians. It's an old Persian culture animal. So I just thought that might be interesting to let you know where that name came from. So having backed up to this, all these instructions laid out on this page, they actually make sense. I followed them. They're very clear. They worked great. I had no problem doing my install. So I recommend this one now as the starting point. Later when Nixie gets fully developed, believe me, I'm moving to it. I really like it. That said, let's get started. First thing you're going to need for Manticore is Java Release 1.8, often referred to as Java 8. You'll hear that said a lot. They just refer to it as Java 8. That's a different version than I used in part 1. And what I'm going to do is I'm going to walk through the Manticore install, and then I'm going to show you the difference between the two, because I'll actually have both versions of the software installed on my computer, and you'll see them both in my directory tree and how they look and how they relate to them. So let's do that. We'll assume we've downloaded it and we've got that ready. We've downloaded everything else that we need as well. Now, since I already have an install, I'm going to demonstrate it from that perspective. So the first thing it tells you to do is install Java. Well, Java installs under the C drive program files. It creates a folder called Java. Now, if your machine already has a version of Java in it, you'll find a subfolder in it. If not, as you're doing your Java install, it will create a subfolder. Each subfolder is named according to the version that you're installing. So we need Java 1.8. So you can see here I've installed Java Development Kit 1.8. I also have Java Runtime Environment 1.8. The difference is what you intend to do. They tell you if you're just going to be an end user of MyRobotLab, all you need to install is the Java Runtime Environment. And that's what you see highlighted on their page here is the Java Runtime Environment. I like to have the development kit on my machines as well, so I installed it as well. So each one got its own folder. Now, I had previously installed Java Development Kit 11, which was needed for the Nixie version. So it's already there. Just remember, if you're running Manticore, you just need Java 1.8, the one listed on the home page there. So with that installed, Java is now ready to go. But as you can see on my machine, I have two versions of Java, which may happen to you because other programs are using Java as well. And so you may find a later, greater version of Java. However, Manticore won't run with a later version of Java than 1.8. So what we have to do now is tell our machine which version we want to use. We do that by setting some environmental variables. Now, since I've been here recently, under my recent column, you can see I have an Edit System Environment tab here that I'll call up. If you haven't been here yet, then you would come down and just type in environment variables down here and pick it from the list. Once you open that environmental tab, you get the environmental variables button. You click on that, you go to systems variables, and you're going to find a couple of things related to Java. Now, Java Home is really used more with the development kit, but since it's on my machine, I set it to the right folder that it needs. And you can go on Google and you can search for how to set these variables, but hopefully just watching me is enough for you to be able to do it. So the secret here is the Java Home has to be set to the root of the development kit. So you go back to the directory tree, you highlight the development kit, and you come up and you copy that address. Then you go back to your variables and you would go to edit. Now, if you don't have Java Home, instead of edit, you type new. And it will create a new variable for you. If you're creating a new, see how it's spelled? It's all capital letters with an underscore, Java Home. That's the name you have to give the new variable. But since I have it already installed, I'm going to edit mine. You can see my variable name and then the variable value. Now, if this was empty, I would just right click and do a paste and paste in the folder name and hit OK. That updates your Java Home. That's for the Java Development Kit. Now, if you're doing a Java runtime environment install, that's not needed. Now, the next step is needed for both the development kit and the runtime environment. You would go down the path and you would edit your path. If this is the first time you're installing Java on your machine, you'll have to use the New button. Pardon me. You won't do that because your path will already have other things in it. So let's skip that New button. Okay, just go straight to the Edit button, and the Edit button brings this screen up. Now, you want to scroll down. My mistake again. Let me stop. Pause this for a minute. Okay, now I'm supposed to be recording, so let's hope we are. The next thing you have to do is you have to set the path. This is going to have to be set for regardless if you're using the runtime environment or the Java development kit. Now your path will always have something in it. I've never seen a computer that had an empty path. So you just hit your Edit button. If you've never installed Java, well, I shouldn't say never because you just installed Java, right? Java should have come up and installed Java Development Kit, Java Runtime. If you've just installed 1.8, yours is going to look just like mine. It's going to point to the Java 1.8 bin file folder, bin for binary files. If you install another version of Java, like I had Java 11, this may point to the wrong folder. And you need to make sure that you set this back to Java 1.8 bin. And you would do that simply like we did the other one. We'd come to Java 1.8, you would open up, go to the binary folder, copy it. On this line you would hit Edit, and then you would paste in the new address and say OK. But I just did that wrong, so I'm going to cancel it because I had the Java Development Kit and the Java Runtime in there, and I don't want to change that. So I'll back out so you can see that again. Got the wrong path, sorry. There you can see I have the Java Development Kit and the Java Runtime. So it depends on how many of these you've installed. If you've just done the Java Runtime, then you're only going to put the Java Runtime environment in here. If you did the Development Kit, make sure you put that in there as well. Now, the reason that you've gone in here and set these variables is so that your machine knows which version of Java to use. Remember, MyRobotLab Manitore needs Java 1.8. So with all that set up, now we can go back to the tree and take a look at things again. So we've got Java installed, and we've got Java 1.8, and we have the binary installed. Now we download the actual Manitore software, and it suggests that under the C drive, you create a folder called MRL, standing for MyRobotLab, and you unzip and install all those files into this folder. Once you do that, you'll see a start immoved bat file. Come to this directory, click on that bat file, and things will start to happen. Now, it's going to take a while, and as they tell you, a lot of different places, go get a cup of coffee and relax, because it's going to take some time. Once it's done, then you're going to come back, and you're going to come back to the same folder, start the same bat file, but this time it's going to see that it's done the install, and it's going to start the program for you. That's the total install. Okay, everything's ready. Now we're ready to use the software, and I'll go into how to use it, the first few files of it. I'm not going to go into a whole lot of detail. I just kind of want to get you started in the right direction so that as you read the files, you can figure things out on your own. So let's open this file and edit it. Okay, so now we're in the bat file, and the first thing it's going to do is kill Java and start it. Make sure it's got a clean Java running. Going to open the log file, or delete the old log file. Going to do the updater. Then it's going to come down here. This is kind of the meat and potatoes of what happens in the bat file. If it says if not exist, and then it checks in the mmove folder for the mmove.py program. If it doesn't find it, then it's kind of bail out and say, hey, program's not available. Please check for it. Maybe do the proper install. Else, if it finds the mmove file.py folder file is installed, then it's going to do, going to do the else. What's else going to do? Basically, it's going to say go to that folder and run the program. So let's see what happens in that folder. So we go over to here to MyRobotLab, open it up, go to folder mmove, and right there you see we have the mmove.py program. That's a Python program. So let's open it up, see what it tells us in here. Open it in Notepad just to look at it. And here it's going to tell you, okay, the first thing we really need to know is how do you want to run this program? Do you want to run it as a virtual robot? Do you want to run it with just the left arm or just the right arm? Do you want to run it, a full robot? So you need to configure that. So it gives you a note right here that kind of tells you about that. And it tells you where to go to change that. So it tells you inside of the config folder, you'll find mmove config file. So let's go take a look at that. So we come back out here to mmove, drop down to its config file, And there it is, underscore move config. And so if we open that, the very first line, it says script type equals virtual. By default, this comes up with expecting no hardware to be attached. It gives you a virtual robot to play with, lets you figure things out safely. Okay, which is nice. Believe me, I broke two pieces of my robot trying to get things going already. So start it up in virtual mode, play with the software a little bit. But once you get an actual robot, this is where you change it to be the type of robot you want to start up. Remember, those are called out for you. Let me get some of this stuff down here out of the way. Yeah, it's called out for you right here. It tells you the kind of startups you can have. I'll let you read that and see all the different types of startups you can have. So once move.py is running, what it's going to do is it's going to create the basic object, the basic robot object. And it's going to say, using runtime, create and start, make the object IO1 of type move. So now we have a basic object that we can build a robot around. The next thing it's going to do is it's going to tell you to do the basic checkup and initialization of the skeleton and the services. And it's going to tell you to do that by using a program called initialcheckup.py. Again, that's a Python program, but it's located in the running folder plus the system subfolder. So let's go find that bad boy. Close up this config file and close up this bat file and get it out of our way. And we'll come back here, move system initial checkup py. So we'll open that so we can study it. And in here, it's going to tell us, well, the first thing we need to do is set some global variables. So it's going to run a globes var.py out of the systems folder. And then it's also going to start up the GUI, the GUI. It's going to start up the parser. It's going to start up the language pack. And it's going to set up and run the errors.py program. All this is located in systems. And that's the folder we're already in. So if you look in here, you're going to see, here's the language pack, here's the GUI pack, here's the robot status global variables that have to be started, and here's the parser, the config parser that has to be started. So that's where all those programs are located. Then the next thing it's going to do is do some initializing. And it does that by looking at the folder, this exec file running folder skeleton. There it is. It's gonna run through that. See, this is a this is a loop, right, for file name in listed directory, running folder plus skeleton. So what it's going to do is it's going to go out here and it's going to find running folder, which is move, and the subfolder skeleton. And for every file in that folder, it's going to loop over them one at a time, and it's going to start those files and run them. So that's how we're going to start things up. So let's take a look at some of those files. Let's take a look at the left arm. Open it in Notepad. Okay, read the current skeleton part config. So it's going to go out and it's going to find the config part for a skeleton called left arm. So it's going to back out. It's going to go to move config, and it's going to run down here and it's going to find the skeleton. See how each one of these has the word skeleton as the lead element before the underscore? So it's going to find skeleton underscore left arm config. And it's going to use this config information. So this is important. These are all elements that you have to define for the robot, for your particular robot. So in the main category, first thing it's going to find out is the left arm even activated? By default, it's false. If you want to use a left arm, you have to come in here. You have to set that to true. Then it knows, okay, I'm going to use the left arm. Then it's going to look at your servos, and it's going to set your bicep, your rotate, your shoulder, and your omoplate motion. And for the minimums and the maximums. That's the maximum and minimum movement that each of these axes can make. So you're going to have to gingerly test your motions as you're building your robot to find out what physics allows you to do. My robot, when I put the shoulder all the way down, it didn't go to complete 0. I needed to stop mine at about 3. And for max motion, I couldn't get to a full 180. I needed to set my motion to about 160 so that I didn't bind anything or cause any bindings. These are the things you need to find out and record them in this file. Another thing of interest in here under the advanced settings is your mappings. You want to map your inputs and you map your outputs. And the outputs down here, okay, your inputs are under advanced. And your outputs, there it is, your max outputs are here. Just under configuration. Now, what's the relationship between input min and max and output min and max? Well, the output min and max are reality. That is what's going to be outputted to your servo on your robot. So that's your physical world. So you're going to set your output mins and max, like I was talking about a minute ago, to your physical world. You're going to map your inputs. Generally, they're going to be 0 to 180, 0 to 90, depending on the type of servo that you have. Now, why do you have an input and an output map? I at first didn't see that relationship, so I got with the guys on MyRobotLab.org and asked the question and came back with a perfectly good answer. Right? If you're going to use gestures that are developed by somebody on their robot, their physical world is going to be different than your physical world, meaning the rotation and movement of your arms and robot is going to be slightly different. And if you use their settings directly, you're in danger of overextending and breaking part of your robot. So we do what's called a mapping. And map is actually an instruction in the Python programming language where you take a range of numbers and you map it to another range of numbers. I think you're beginning to see a relationship here. So if we're all using an input range of 0 to 180, we have kind of a standard to map to. And I'm going to pause. My wife's going to have me eat, so I'm just going to pause for a minute. Okay, so I'm back from lunch. And as I was pointing out, we're talking about the mapping. So if you have a kind of a universal standard for the inputs 0 to 180, no matter who writes the gesture, if they talk in terms of 0 to 180, they can use 180 as I want it full motion on their robot, but it maps to you in reality as maybe 165. That's the basis behind that, and it protects your robot. So those are good things to know. So we've kind of gone through the basics of how the robot gets made, how the startup files start, how the skeletons get configured. The services go through the same thing, but they have their own little config file. Like here's the PIR file. And the first thing, of course, is it even being used, true or false? And then you get to tell it, okay, which Arduino is it on? Is it on the right side or the left side? And what is the control pin used for the PIR? So you get the flexibility of being able to move it from one side to the other and put it on a different pin, different things of that nature. Your service then knows what to do with it. One that pops up, I saw pop up a lot in the questions, when you're trying to use the NeoPixel ring, right now it runs on its own Arduino, and so you have to go into service 6 here, the Arduino. You have to open it and modify it. And you tell it what COM port you're on. And well, I'm sorry, that's the COM port. This is basic COM ports, right? For your right port and your left port, you give it the COM assignments. So that's how your right port and left port get configured. You come in here and set the port numbers for it. The NeoPixel, NeoPixel, this is the one I was talking about. Now open the other one by mistake. Basically, it's the same thing here, right? You're gonna tell it where it's at. Is it on the left board, right board? What serial port is it on? Okay. If you're on Windows and you set that up as a COM port, when it sees COM, it doesn't matter if you set it to left or right port. It will ignore that. It knows based on the word COM that it's a separate board. So those are kind of the first run throughs that I've had with the configuration and the setup of things. That's how you kind of get up and running. I'm going to go ahead and close this section out for now, and I'll do a part 3 where I actually open up the software and let you view some of the screens and see how to maneuver through the setups. All right, with that said, let's just leave it where it is and close things up.